think we're going to start, and there'll probably be a few more people to come in, and that's good. Okay, everyone. Hello there, and welcome to this tutorial about decorators. My name is Reuven Lerner. I'll give you a few moments about myself, and then I'll tell you what we're going to be doing together, and then we will jump right into things. So I have a great job. I teach Python every day, just about. I'm in a different company around the world, online, in person, teaching them Python and pandas. People who don't know Python, I teach them. People who do know, I help them to improve their skills. People who already know a bunch, I do all sorts of exercises. I have books of exercises. I have newsletters. I have YouTube videos. And at PyCon, I actually have feedback. No, I want to get feedback from you, not from the sound system. No, I have a booth, and you're welcome to come by and learn more about what I do. But you're going to see what I do over the next 3 hours or so. We are going to talk about decorators, one of my favorite topics to talk about, in part because it brings together so many different things that Python does and that does well, and in part because people are utterly mystified and confused by decorators, and I'm hoping to confuse you more. No, wait, I'm hoping to confuse you, really make it sort of obvious how all these different parts of Python fit together, how decorators work, how you can use them, why you would want to use them, and along the way, get a whole bunch of practice doing it. So I hope that all of you have Python installed. If you don't, like, you're at the wrong conference. And we're going to do, as I said, a whole bunch of exercises. I am a big fan of people asking me questions, people stopping me, people telling me where they are confused. This is a fairly large group. At the same time, if you are confused, probably someone else is confused too, and you are doing them a favor by telling me that you don't understand what's going on. So I will stop often and ask if there are questions, and if you do, don't be embarrassed. Please don't be embarrassed. I want to help you. Also, when we're doing the exercises, I want to walk around and help you out if things are going wrong. It might be small, annoying technical things, and it might be big, annoying technical things. And I just learned a few days ago from my friend Trey Hunter, who's also done a tutorial, who's also a Python trainer. He said, you know, it's really hard for people to raise their hands while they're coding, because then, like, what do you do with your hands? So he gave me this idea of Post-it notes. So if you have a question, and you want to ask the question, but you want to keep coding and keep trying at it, and I haven't gotten to you yet, there are Post-it notes on the edges of all the, like, at the ends of all the tables there, and you can just ask people to, like, pass it along to you or something, or you can just do it. Wow, that's great. And then if you put it on your computer and I can see it, then I will come by and try to help you. I'll try to do this as best as possible. As I said, big group, but let's see what we can pull off together. Also, as I wrote to you in email, I guess it was like a week or so ago, I don't use slides when I teach. Rather, I use Jupyter, and so I've got Jupyter installed here on my computer. The problem is Jupyter is really bad about people sharing more than one person sharing the same notebook. So basically, I've got this thing running on my computer called git auto push, and every time I save in Jupyter, it commits and pushes it to GitHub. And so if you go to, let's see, here, I've got it right here, bloop, 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 bloop. So if you go to, you know what, I'm just going to copy, I'm going to copy this URL and put it in Jupyter here. So, Jupyter repo, wow, that's a great start. Well, it's going to be a terrible, okay, so Jupyter repo for this tutorial, and it's just going to be there. And so if you go there, basically there's a Jupyter notebook in there that's read-only. It will be updated every few minutes. You'll get almost in real time what I'm doing. It'll also stay open after the tutorial is open. So if you want to review things, you'll be able to do that. You do need to refresh your browser every few minutes to see what updates are there. It's not going to do that automatically, but this is a way for you to see what I'm doing without, like, being on my computer and so forth. All right. So given all of this, like, let's do a little agenda here. What are we going to be talking about today? So first thing, we're going to talk about, like, well, you know, what are decorators? And what are they involved in? How do the different parts of things that we're going to be using in Python? Then we're going to talk about writing your first decorator. And then we're going to talk about outer function storage. We're going to talk a little bit about inputs and outputs and what we can do. Then we're going to talk about decorators that take arguments. All right? And then we're going to move into nested decorators. And then we're going to talk a little bit about decorating classes. And if we can squeeze it in, also writing decorators as classes. See if we can pull that off. Worst case, I'll just talk fast. So any questions until here? Yes, Rodrigo. Uh-oh. Is this better? Yes? Good? Okay. Sure, sure. This is the sort of thing you don't have to wait to tell me. You can just say, you really should have shaved. All right, anything else? Fantastic. So let's start off by talking about then, like, what are decorators? Now, many people who have sort of studied some computer science or some programming and have learned a bit about design patterns, they're like, I know what decorators are. So let's start by dispelling that myth right away. Python decorators have almost nothing to do with decorators and design patterns. All right? But they are super cool and powerful and interesting and useful in all sorts of other ways. So the way I like to introduce decorators is with a little story. So let's assume that we have two basic functions. And these are really silly small functions. You're going to see def A, and it returns A. And I have def B, and it returns B. Very exciting, right? And I can say print A and print B. And I run these functions, and sure enough, I'm going to add some new lines there to avoid problems later on. That is not a new line. OK, we have A and we have B. So far, so good. And I am like, super happy. We've rushed this to production. Our customers are happy with our amazing functionality. And then, you know what happens. My boss comes in. My boss says, listen, we've gotten a directive from above in the company. Now, everything we print out must have lines, dashed lines, above it and below it. And I sort of roll my eyes, bureaucracy, the company, everything. And I'm like, OK, I know what I can do, because I am an experienced programmer. I will copy and paste. And I'll say here, lines equals minus times 60 plus new line. And then I can just go in here, and I can say lines, lines, and lines, and lines. Ta-da! Huge success. Except that I realized this is not a very good way to do things. And years ago, when I read the book called The Pragmatic Programmer, they taught me the idea of the don't repeat yourself, the dry rule of programming. Right? And so right now, we have a technique that will require us to repeat or to include lines in every function we write. That is like the epitome of repeating ourselves. That is the epitome of repeating ourselves. And so what we have to do is try to avoid that. We want to sort of extract that from inside of our functions so that if I have a new function, I don't have to include lines there explicitly. So how then, how can I do that? I include lines without having to include that variable explicitly in every function. So let's do option one. I'm going to write a new function. And this is where things start to get tricky already. I'm going to write a new function that takes a function as an argument. What the heck do I mean by that? Well, I'm going to take my A and B from before, my earliest versions of A and B. And I'm going to bring them down here. And I'm going to say, OK, I'm going to add, well, I'm going to say lines equals this. What do I say? Times 40 plus. Doesn't really matter. All right? And then I'm going to do this. I'm going to say def with lines, func. And then I'm going to say something really wild. I'm going to say in my f string, lines, and then func, parentheses, and then lines. What am I doing here? I'm writing a function, and on the surface, it's a regular old Python function. It's a function that takes an input, and it's a function that returns an output. What is the input? A function. What is the output? A string. OK, sounds pretty reasonable, but wait a second. What do you mean I'm going to get a function as an input, as an argument? Yes, functions are what we call first-class objects in Python, meaning functions are objects. We think of them as verbs, but they're also nouns. We can store them in variables. In fact, when I define a function, I am actually assigning to a variable. It's a variable that refers to a function object as opposed to an integer, a string, a list, a dictionary, or anything like that. So I can pass a function to another function as an argument. And then inside of that function, I can call it. I just say func parentheses. And whatever that function returns will then be stuck into the return string, and then we'll get it back. So now all I have to do is say print, not A, but print with lines of A, and print with lines of B. And if I do this, it actually works. But wait a second, look at what I'm doing here. I am not executing A, and I'm not executing B. Right? To do that, I would have to say A parentheses, B parentheses. I'm not doing that. I'm passing A and B to the withLines function, and then withLines is executing it here, func parentheses. So I'm not executing A and B. The function that I call is executing A and B. And now it's fully scalable. Now I can write any function I want. By the way, that's a lie. Now I can write any function that I want, call it within withLines, and all is good. And I am so proud of myself, and I show it to my boss, and my boss says, this is awful. You've broken the API. All of our customers expect to be calling A and B, not this withLines junk. What's going on? I say, oh. So we're going to have to work a little harder at this, but that's OK. So what's option 2? Option 2 is turn withLines into a function that returns a function. That is, we're going to create a closure. Now, what do I mean by that? I mean that withLines now, when we call it with func, it's a function. We're calling it. What, can I define a new function inside of another function? Yes, absolutely. Excuse me. So I can do this. I can say def wrapper return f of this. And then I say return wrapper. Now, if you've never seen an inner function before, or if you have and you've run away, they seem super weird. Like, what do you mean? Like, when is everything happening here? So let's think about it. When I say def withLines, when I say def any function, when I define a function, the body of the function does not execute. When I define a function, the body of the function is compiled, is turned into bytecodes, is made ready to actually do something. But only when we actually execute the function does the function body execute. By the way, it makes sense when someone says it, but we often think, oh yes, I've defined the function, I'm going to run it. No, no, two totally separate things. So when is def wrapper going to run? When are we going to be defining wrapper? Only when we run the withLines function. Only then is it going to run. So if I call withLines, we define wrapper. Wrapper is then a local variable. It's only available inside of withLines. Wrapper does not exist outside of that function scope. And then what do? We do something super weird. We define this function, and we don't execute it. We return it. What we get back from calling withLines then is a function. It's a function that then we can call. So when I now say, watch this, I'm going to say here, withLines A equals withLines of A. And withLines B equals withLines of B. And so what we're doing here, and I can just say print withLines A and print withLines B. Now let's just review what we've got here. So I've defined lines. That's like the easy part. I define withLines, this function that's expecting it a function. Every time we call it, we're going to return wrapper. Wrapper is then going to return a function when we call it. Is going to return it with lines, and then in the middle, whatever we get from executing that function. But wait, how does it have access to this? Because func is a parameter. It's a local variable belonging to the outer function. How can wrapper refer to it? And it turns out that Python scoping rules, the LEGB rule, local enclosing global built-ins rule, allows for this very explicitly. If you have a function defined inside of another function, the inner function has access to the outer function's local variables. Do I have access to those local variables from outside the function? No, I do not. They are private to the function, except that inner function there has access to them, which is super weird and very useful. So if I now call, so I define A, and then I immediately do what? I call withLines on A. So withLines with A, we get back wrapper, and we assign it to withLines A. This is a new function we've defined, which is referring to the wrapper from there. And then I do the same thing with B. And guess what? withLines A refers to wrapper with A in func, and withLines B refers to wrapper with B in func. I have two instances, for lack of a better term, two instances of wrapper. One that has A there and one that has B there. Let's see this graphically, because this, again, can be a little tough. I'm going to go to the Python tutor. This is such a fantastic site. When it loads. Let's It's not like we're at a technical conference where we need good internet service, right? All right, who's doing the torrent download? All right, so one of these days it will come, but meanwhile, basically we have to sort of keep track of a whole bunch of things in our heads here. Now, does this all work? And the answer is yes, it works great. When I call the function with lines A, I get back that string with the lines, the output of A, and lines again. And when I call with lines B, I get lines and B and lines. And that's done, by the way, dynamically. It's not like it's stored some output from before. When I call with lines A is executing. When I call with lines B is executing. So this is pretty cool. There's just one problem with it, which is I still haven't satisfied my boss. Right? I've still broken the API. So let's do option 3. And this is where things get really wild. Don't assign to with lines A and with lines B. Rather, assign to A and B. Oh, you know what? Here we go. Of course, now it's working. Grr. All right, so hold on a second. Hold that thought. Okay. I clicked on a link, right? What could possibly go wrong? Oh, my God. All right. Fine. We'll come back to this in a moment. OK. So what am I going to do now? I'm not going to call this with lines A. I'm going to call this A. I'm not going to call this with lines B. I'm going to call this B. Now, this seems cuckoo, right? I'm defining A, and then immediately I'm turning around and saying, actually, I want to redefine A to be the result of with lines A. It's like taking something and sticking it in a wrapper or a decorator, right? And so B, we're wrapping it up there. So if I now call the function A, which function am I really calling? Wrapper, the inner function defined in that context with A. And if I call B, what am I getting? Oh, I didn't want to do with lines A. I want to do A and B. B. Look at this. I've now preserved the original API, and I have this new functionality. Yeah, but this is still kind of ugly and weird. I'm defining A and then immediately redefining it. I'm defining B and immediately redefining it. So we're now on, wait, let's see if we can do this. Yes. OK. So watch this. I'm going to do this here. No, not that. That. Come on. Just copy the whole damn thing. All right, and we can do it down here. And I want a new version of Python, and this should be good. So let's now go through this code and see what's actually happening. So first I'm going to define lines. OK, that's like the easy part again. Question. Oh, please, please. Excellent.
When you redefine A right away, does it do some sort of name mangling under the hood? Because it's the same exact name, variable function name.
Fantastic. No. Watch this. If I say this, so if I say now, like x equals 5, and then I say, actually, x equals 7, I say print x, what's it going to say? 7. Does it remember that x once referred to 5? No. And in the same way, when I assign to a variable that previously held a function, the previous function, like you can think of it always as an arrow. And we're going to see this now in the Python tutor. That's one of the beautiful things it does. When you use def or when you use assignment, you're basically saying, I want this variable to refer to this object. And if you do assignment, it just moves it.
You weren't using A still. The old A.
The old A, watch this, watch this. OK, so we're now going to define with lines. With lines, I'm just going to edit this and make it a much, much, much shorter thing. I'm going to say 4, not 40.
Sorry.
Yeah.
Would it be possible to make the text a little bigger?
Yeah, absolutely. Sure thing. OK, so we've got lines now. And now I'm going to define with lines. And with lines is what? It's a function. So there's a global variable referring to a function object. So far, so good. So far, that's normal. And A also is a global variable referring to a function object. So far, so good. And now what are we going to do? A equals with lines of A. Whenever we assign in Python, the right side executes before the left side. So what's going to happen? We're now going to execute with lines. When we execute a function, we get a new stack frame. There we go. This is the stack frame for running the with lines function. We have a local variable func, and it's referring to A. So we now have 2 ways to refer to the function A. We have the global variable A, and we have the local variable func. Not for long. What else are we going to do inside of with lines? We're going to define wrapper. We now have 2 local variables, the local variable func, which is referring to A, and the local variable wrapper, which is referring to this new function that we just created. Notice that right away also, the stack frame in the Python tutor does not just say it's from with lines. It says it's F1, frame number 1. It knows. Because now the function returns. What does it return? It returns a wrapper. And watch what happens now. A, the global variable, is referring to wrapper. Wrapper that was defined in this context of with lines. The context in which func refers to the original function A. So the only way we have to get to that original global function A is via wrapper. And the only way we have to get to wrapper is via the name A. So basically, we've now hidden that original function. The only way to get to it is via wrapper. And we do the same thing with B. So now we call with lines, and we get func, and we get wrapper. And now B, the global B, refers to its wrapper, which was defined in this context with a func that refers to function B. But the global variable A no longer has anything to do, directly at least, with the original function A, and the global variable B no longer has anything to do with the global function B that we had created before. If you can make sense of this in your head, and you will, I promise within 20 years it will happen. Once you have this crystal clear, like the rest of this is a piece of cake. And what I'm going to try to do over the next few hours is make this clearer and the options that are available to us. But first, we'll just make sure this works. And it looks like it works. Da, 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 da. Right? Oh, actually, let me go back for a moment. Because watch this. Now when I call A, when I call the function A, what is it going to do? Let's see. Let me go back here. Where am I? I'll return wrapper. OK. So now I call A. What am I really calling when I call A? Wrapper from that first stack frame. So here it says wrapper, parent is F1. OK, what are we going to do inside of wrapper? Well, we're going to call func. What is func? Well, let's check what it says in the parent of F1. Func is the original A. So we're going to call the original A. Watch this. New stack frame. Call A. It's going to return A. We get that back. Now we have the return value of the lines with A. We return that. And all is good. And we've printed it out on the screen. So basically, we're introducing a new level of indirection here. I'm no longer calling my function directly. I'm calling my function via another function that I've wrapped around it. Hence the term wrapper. Let me stop right there and see if there are more questions. Like, can we get a stiff drink? Yes?
What's the benefit between like having the wrapper and just having the function that just inputs func? Like, what's the benefit of actually using the wrapper there?
So there are two reasons. One is we're going to see the official decorator syntax in just a moment, and it requires that we do it this way. The second part is once we have two functions to play with, the outer and the inner, the outer is called only when we actually decorate the function. It's like basically the outer function is called when we define our function, and the inner function is called every time we call our function. And separating that definition time from that call time gives us a lot of opportunities to play with it. Bottom line, we can now hijack our function either at creation time or at runtime and do whatever we want. Substitute other inputs or whatever.
Okay, so it sounds like we'll understand more later.
Yes, I hope so. Yes. Yes, please.
Probably a dumb question, but what is the difference between a wrapper and a closure and a decorator?
Oh, good. Okay. So we are now seeing a decorator. We just haven't used official decorator like syntax. Okay.
It seems like those terms are sometimes used.
Yeah. So wrapper is just like, I think, a colloquial term that a lot of people use to describe the function because that's how we think about it, as like wrapping the function. And a closure is a very old school computer science-y term. And it basically means when you call a function, you get its inner function back that has exclusive access to the outer function's local scope. And people have described this. Closures were invented long before object-oriented programming, and people have described them as inside-out objects. That instead of having data with functions you get to, you have a function with data you can get to. And certain languages like Lisp really loved using closures for a long time. Sure. Other questions? Yes, please.
So, could you review again why we want to use A with like the with lines?
Mm-hmm.
Why couldn't we just use a different term or variable instead of calling A again?
Oh, you're going to see in just a moment. Okay? Other questions that I can hold you in suspense with? Okay, so let's go back now to our code, and now we're going to pull this all together. Now I'm going to take all this, and I'm going to say, I'm just going to turn on the line numbers. There we go, that makes it a little easier. Okay, option 4, use Python decorator syntax. Okay, you see what I did here in line 12? I'm going to call it line 13 now. See what in line 12? After defining A, I then say A equals with lines of A.
Would you mind just copying and pasting that into a new block?
I did.
Oh, you did?
I just did, yes.
Sorry about that.
No, it's fine, it's fine. But I'm glad you said that because, yes, like little by little I've learned to do that as opposed to, oh, what, you want to actually see what I did before? No, you're right. So watch this. I define A, and then I say A equals with lines of A, and I have here 3 different functions. I have the function that I'm decorating, the original A. I have with lines, second function, and then I have the return value of with lines, which is wrapper. I'm now going to do exactly the same thing with less syntax. I'm going to say @ with lines. This is 100% equivalent to what's in line 13. And this is decorator syntax. Basically, what happens is, when I say @ with lines, it tells Python, first go ahead and define A. And immediately after doing that, turn around, call this thing, which has to be a function. Actually, it has to be a callable, so we can make class also. So this has to be a function, basically. We're going to pass our function to it, and whatever we get back is going to be assigned back to A in its stead. And so that's one of the reasons also why we need to have these 2 functions, because Python expects that we can call a function, and we'll get a function back from it that we can use to replace it. And then if I say here, @with lines, I'll put this in, and now I call A and B, perfection. And now I'm happy, and my boss is happy. Does that mean I'm happy? Depends where you work. All right? So basically, this is what decorators are. Decorators are when we take a function and we wrap it with some other function, and that allows us to do things. Yes, please.
From my last talk, it said that is awesome. Was there a difference when you run with that and without that?
Yeah, well, there's no difference between this syntax. The @ means the thing that I'm about to define, we want to do with this. If you don't use the @ you must do it with this way. But you can do it either way. They are equivalent. This is considered more normative in modern Python. But there are places, for example, the property decorator. If you use @property in your class, you could equivalently say, like, whatever equals, and call property afterwards. No one does that, but you can. Yeah, please. So every time you want to apply a decorator to a function, you must use the @ syntax, right? There's no, and for the rest of the program, I want to use this, right? So it's scoped to one thing. So you might have a whole bunch of functions where it's @this, @this, again and again. In fact, like if you use Django or Flask or something, you will often have the same @ stuff above all of your functions. That's because those are decorators that are messing around with the functions. Anything here and here? I just gotta look on my peripheral vision as well. Okay, so this raises the question of who needs this? Right, like why do we need this? And first of all, this is what we call in the consulting business an opportunity. But separately from that, right, so basically, sometimes, so this, first of all, the biggest thing is if I have many functions that need to do the same thing, I can extract that functionality into a decorator and thus dry up my code, right? I can stop repeating myself so much. That's fantastic. But that's the very general case. I can use it for if I want to, timing my functions. I can use it for security of my functions. I can use it for setting values before and after, right? Like setup and teardown. I can use it for, logging. I can use it for checking or filtering inputs. I can use it for filtering outputs. Right? The list goes on and on and on. In fact, there are a huge number of cases in Python that used to be really complex to do. Right? Sometimes people talk about meta classes, right? Like I want to do also, and those just sort of go away because decorators do all sorts of things because of this ability to hijack the function both when it's defined and when it's actually used. Okay, So let's say, by the way, we're not quite done with lines because there is still a problem with it. What's the problem? Let's decorate another function. So I'm going to say here def add x and y. I'm going to say here return x plus y. And I then say print add of 3 and 5. Shockingly, it prints 8. But hey, let's say with lines, right? I want to do that. So now it should give me the lines, and 8 really okay, fine. If we want to make it a little more aesthetically pleasing, we'll do this, and we'll put a new line there, fine. But it doesn't really matter because I try running it and it blows up on me. Well, what's wrong? Well, it gives me a fantastic error message. With lines wrapper takes 0 positional arguments, but 2 are given. What the heck? Well, remember, when I call add now, because of this, I'm not really calling add. I'm calling wrapper inside of with lines. And if we go back to the definition of wrapper, what are we going to see? Wrapper takes 0 arguments. It is 0 parameters. So we are calling this function with too many arguments. Well, what am I supposed to do about that? I'll have to rewrite wrapper. So I'm going to say here, def with lines wrapper, splat args. You can also say double splat kw args. I'm going to ignore that for now. Okay, so now wrapper takes as many arguments as we want. And now if I go and I decorate add, and now I go here and I use it, will it work? And the answer is no, don't be kidding. It says now add is missing 2 required positional arguments. So the good news is that when I called add with 3 and 5, I was really calling wrapper. It took those arguments and it was totally fine with that. So far, so good. And then I called func. What is func? It's the original function. It's the original add. What arguments did I pass to it? Nothing. And so it's complaining, hey, you need to provide me with 2 arguments to match my 2 parameters. So what do I need to do? I need to modify this so it not only takes splat args in its input, but it uses splat args, meaning basically take any number of positional arguments, create a tuple, args. And then here it's turn args into arguments to func. In other words, we're sort of getting all these arguments, 3 and 5, turning to a tuple, and here we're unrolling that tuple into arguments. Now it's going to be func of, parentheses, 3, 5. And we do this, and we're golden. If we do this with splat args, and even more so, if we do this with splat args and double splat kw args, with both of them, you know what we have? We have a decorator that can work with literally any function in Python. It doesn't mean it'll be useful with every function in Python, but it will work with them in terms of the inputs and in terms of the outputs. And this is a simple but working decorator. It has the outer function. So let's summarize what we need to do here to write a decorator, and then I'll have you do it. So how to write a decorator. Sounds like a Martha Stewart thing. Okay. Number 1 is, so the outer function, the decorator, takes 1 argument, a function, right? So func. Right? This is the function that will be decorated. And this outer function is invoked once when we define the decorated function. Okay? The inner function, typically called wrapper, takes splat args and maybe double splat kw args, and it does whatever, it is invoked every time the original function is invoked. And so it can do whatever it wants with the arguments and outputs. And so after defining the inner function, the outer function returns wrapper. By the way, I forget to do this all the time. If you get an error saying, I can't invoke things on none, chances are you made that same mistake. Okay, and then we can then decorate any function with splat outer decorator name. That's basically what's involved. So, questions or comments until here? Yes, please.
How do you handle a situation where the desired output changes because you decorated a function? So, for example, in wrapper, you're wrapping it as string.
Mm-hmm.
The original function was returning a big part of object or data type.
Yeah, don't do that. I mean, basically, like, you know, the old saying that, you know, Python and many other languages will give you as much rope as you need to hang yourself. So, like, you basically, like, can, with decorators, do all sorts of crazy stuff. Try to stay within the bounds of reasonableness. I mean, basically, look, at the end of the day, it's up to the individual developer. You could argue that with type checking, it becomes easier, like if using MyPy or something like that with type hints. You could also argue, well, I documented it, and everyone reads documentation, so we're set. I sense skepticism in the audience. Okay, let's do this. This is, oh, please, I'm sorry.
Why do you need to ask it in front of args when it's the input of the function the wrapper is calling?
Oh, so when, if I were to write, here, watch this. If I were to say like def my sum of numbers, right? So, total equals 0 for one number in numbers, total plus equal one number, and then I say here return total. So if I now say my sum of 10, 20, 30, how many arguments am I passing this function? 1. It's a list with 3 elements, but it's 1. What happens if I say my sum of 10, 20, 30? Passing it 3 arguments? Python says, you got to be kidding me. I can't do that. I take 1 argument. But if I were to change this function to be splat numbers, now the function takes any number of positional arguments. And now, if I say my sum of 10, 20, 30, what happens? This numbers is a tuple. Is a tuple of all of the arguments that I pass to it. It's basically saying pass as many as you want. Now, you could argue that I prefer to write a function that takes a list, and that list will contain all of them. But there are many, many places in Python where it's actually either useful or necessary. Like here in Decorators, I don't know how many arguments are going to be passed, and so I can't dictate it at the beginning. So I have to be flexible and say, whatever you want to pass to me is OK. And so this will actually work now, because now I'm passing 3 arguments. Those 3 arguments will go into the tuple, and we're all fine. Mostly, OK. Oh, so in there, so then we have to sort of reverse that. Then basically, if I were to take func, the function, and call it with a tuple, then it would freak out, because add does not know what to do with a tuple of 2 numbers. It knows what to do with 2 numbers as arguments. So the splat there in front of args in the function call does the opposite. It says, I have an iterable, and I'm going to sort of remove the parentheses from the outside so they become arguments. It's like the opposite, but yeah, people don't talk about that nearly as much. They should. I just did. Other questions or comments? Yeah, please.
Would you mind repeating questions so that folks before hearing like myself and the recording know what you're asking?
So he's asking, could I repeat questions? Yeah, so people with poor hearing will understand, and the answer is no. Yeah, I'll do it. OK, so let's now do a little exercise to play with this. All right, so let's call this shouter. So what I want you to do is write a decorator, shouter, that that decorates functions that return strings. Sorry, so we'll like limit it there. All right, and so any such function's output will return all in caps and with an exclamation point at the end. So as an example, if I were to say here, right, def, let's do this. So I say here def hello name, and I say here return hello name. Well, I'll just leave that off. If I were to say here shouter of this, and then I say print hello Reuven, it's going to output hello Reuven exclamation point. OK, and I'll give you a hint. Number 1, use stir upper. And number 2, use exclamation point. All right, that second hint was probably a little unnecessary. OK, so let's work on it for a few minutes. I'll sort of look around. If you have questions, raise your hand. I'm happy to come over to you and try to help. If you prefer to put the Post-it up, I'm going to try this, see how it works. And we'll look over this in a few minutes and then go deeper into these things. So let's go over this together. Ooh. So I'm now going to say def hello name, return hello name. Okay, and if I say now print hello Reuven, works just fine. But now I want to decorate it. So how am I going to do that? So I'm going to say, first of all, def shouter func. So this is my outer function, also my decorator function. And it's going to run every time I decorate a function. Excuse me. So I'm now going to say def wrapper splat args, because the inner function runs each time we invoke hello. And then I'm going to say return, and I'll say here func of args. That would be, well, if I put it in curly braces, this will return exactly what we had before. So let's start with that, return wrapper. So if I do this now, I'll also have to decorate it, shouter. So now I get exactly the same thing back. But if now I say func.args, right, so that's going to give me then, that I can say dot upper. Now it's all in caps. And then I can add an exclamation point there. And there we go. Fun for the whole family. If you're a family of nerds. Okay? Questions or comments about this? Yeah, please.
So in this case, I'm struggling to understand why you wouldn't just change the function. And let's say in this case, if you wanted to just be a shout, why not just amend the hello function? But you still kind of understand why.
So if it's one function, you're 100% right. The idea of a decorator, though, is I have the same thing I want to do to a whole bunch of different functions. And so it just becomes unmaintainable, unsustainable. Like, every time I add a new function to the system, I want to do the same thing, then I've got to have the same boilerplate code, right? We want to avoid as much as possible copying and pasting code inside of our functions, even though we all do it, right? But we want to avoid that, and so decorators are for that sort of case. So if I had many functions where I wanted to have them all output in caps and add exclamation point, right, then this would be useful. Questions, comments? Yeah, please.
Still getting the missing required positional argument.
So it's probably because when you're calling, you have to make sure you have splat args in two places. One is in wrapper, and the other is when you're calling func. You have the, okay, so let me come over and take a look.
Sorry.
No, this is what I'm here for. All right, let's see here. Okay. Oh yes, that's the problem. Okay, excellent point. Right. Okay, but let's look at that. So basically, when you return wrapper here, you are returning the function object. You are returning wrapper so that someone else can execute it. You are not executing it here. If you execute that, then you're returning a string or something else. Or, as what happened to you was, Python's like, oh, you want me to execute wrapper? Sure, you defined it, I'll execute it. And then it's like, wait, but I don't have enough arguments for it. Actually, there it does have enough arguments, except when func, oh, so the problem was with func, yeah. Huh, cool. I mean, I think it's kind of cool, but you were like, oh, what's going on? All right. Let's try something a little deeper, more interesting. Let's do timing of functions. So I want you to write a decorator, let's call it timefunc, that will not change the inputs or outputs of the decorated function. However, it will keep track of how long it took to run the function and will write its results to a file, let's call it timing.txt. So every time I run the decorated function, I'll get another line in timing.txt with the function name, B, when it was started, and C, how long it took. Now, a few things that will be useful, hints and ideas, let's call it hints. Number one is you can write, so normally, writing to a function, writing to a file with W will overwrite the file's contents. You should open a file with append, and then that won't happen. Number two is, let's see what I want to say. You can get the function name from the under name attribute. Number 3 is you can get the current time, Unix time, seconds since 1st of January 1970, with time.time. I know it's not the best way to time things, but shh, don't tell anyone. Okay, so basically I should be able to do something like this. I should be able to say like at timefunc, let's say here def slow add of A and B, time sleep, let's say like, well, let's even do this, import random and import time. And I say time sleep of random randint of like 3. And then I'll say return A plus B. So this adds 2 things, but it takes its time in doing that, which is fantastic if you're paid by the hour. All right, and then here I can say mul, I'll do the same thing with times. And then I should be able to say like print slow add of 2 and 3 and print slow mul of 4 and 5, and they will give me the right answers, but we will then have in timing.txt how long it took for them to run. Okay, so this is definitely a little more challenging. At the same time, it's built on these same ideas that we've been talking about. So give it a shot. This is already, I'm trying to like juggle what's shown here. It's also on GitHub. Let me know if you have questions or problems, and I'm happy to come around and take a look and so forth. Okay, and we'll give this a few minutes, and then we'll look over it together. No. You can. So the question is basically, if I have a decorator, so let's say I have an add function that returns the sum of numbers. Okay, so far so good. And I decorate it with logging. Do I then lose the input and output of the original function? The answer is not necessarily. It depends on, the decorator can decide. Right, so you can have a decorator that's like, I'm just throwing everything in the garbage and returning 5 each time. Not recommended, but right, you could. But this kind of decorator with the timing, it should keep the inputs exactly the same and the outputs exactly the same. It'll take longer to run, but that's not like, that's sort of the trade-off you have.
So like in this case, if I'm writing to like a text file, I can also just have it return whatever the sum.
100%. The point was like you can have it write to a text file and also have it return a value, and yes, exactly right. Let's give this another 2-3 minutes, then we'll look at it together. Let's look at this together. So I'm going to copy what I did here. I'm going to put this into Python mode. Okay. So we've got my slow add and my slow mul, and we're going to call them. And now I just have to write my decorator. So I'm going to say def timefunc, and that takes a function as an argument, and that's it. Okay. Now I'm going to say def wrapper splat args. Okay, also good. Now what? Well, let's start off with it just getting the inputs and returning the outputs, not doing any logging at all. So I'm going to say here, value equals, let's say func of args, return value. And then I'm going to say here, return wrapper. If I do this, it should work. 5 and 20. Okay, I was always wondering about those results, so it's good. So basically, so far so good. Now I want to add the logging. So now I'm going to say here something like this. I'm going to say start time equals time.time. And I'm going to say here end time equals time.time. And I can say with open timing.txt for appending as f. I can say f write of, I'm going to say here, func dunder name. That's going to give me the function name. I'm going to say here start time. I'm going to say here end time minus start time. I'll do a new line. And so now what's going to happen is every single time we call a decorated function, it should write something to the log file and still give us output. That ran rather quickly. Let's try this again. Okay, and now, if we look at timing.txt, oh, it actually ran twice before. I guess it was just very slow, very fast. And sure enough, we can see slow add and slow mul, slow add and slow mul, and it ran. We know when it started, and we know how long it took. Pretty snazzy. And what this means also is, let's say I have a function that I'm not sure how long it's taking to run. I can stick the decorator on it just while I'm sort of working on it, debugging it, and I can remove the decorator, and I haven't touched the code itself for that function, which is kind of nice. And even better, let's say I realize that maybe this kind of thing is not, it's not the smartest way to run it. I can modify my decorator at some point to use some sort of asynchronous or like, celery, something like that in the background instead of opening the file myself and waiting for it. And then I've improved my decorator and improved my timing for those functions. Everything is sort of separate, which is kind of nice. Yeah, please.
If the decorator is returning the value, why don't we see two values? Like when you print it again.
Well, it's returning the value to print, right? So I'm calling slow add with 2 and 3. That's really calling wrapper. And here is where the original slow add is being called. So slow add, like the original slow add, it's very hard to keep track of, I know, with like a limited vocabulary here of like function and slow. But slow add, the original one is being called. It is returning its value to wrapper. Wrapper is returning its value then to print, and print is printing it out. Okay. Other questions or comments? Okay. So we've now seen like a bunch of, nice, good, useful, if simple decorators. But here's the thing, using the outer function. So when we have an inner function, it has access, as we've seen, to the outer function's parameters and local variables. However, we can go further than this, storing data in the outer function. And that data persists across calls to our inner wrapper function. This is pretty great. So how are we going to do that? Well, let's do this. I'm going to say here, yeah, let's do this. So let's say I want to know how many times a function has been invoked and print that to the screen every time we call it. This is super annoying, right? And not practical, but it'll do the thing. So let's get here slow add and slow mul. I'm just going to abuse them a lot for the next little while. Okay, but instead of saying time func, we're going to say count calls. Count calls. Okay, so now I'm going to say def count calls. It's going to take func. Say def wrapper. It's going to take splat args. I'm going to say here, well, let's just get value equal. Let's just do this. Yeah, sure, value equals func of splat args, return value, and then return wrapper. If we just do this once again, we've not done anything much in our decorator, right? And so I call it, and it prints 5, and it prints 20, and we're doing great. But I want to keep track of how often we've run each function. Well, how can I do that, right? What I could do is say something like, call counter, or let's just say counter equals 0, and then I say counter plus equal 1, and then I say print, counter equals. I'll even do this. I'll say func dunder name. And so if I run this here, it's going to say, well, slow add was called once, and slow mul, let's even do this 2 or 3 times. Now this is going to work terribly. Why is it going to work terribly? Why is it going to always tell me that the function has been called once? Because counter is a local variable inside of wrapper. Each and every time I call wrapper, that variable is going to be set to 0. It's going to be created anew and set to 0. And so this means now that I'm not counting anything. This is completely and utterly useless. So I can, though, move this to the outer function. And that outer function sticks around because of the whole properties of a closure, because the inner function has access, exclusive access, to the outer function's variables. And if we update counter now, it will stick around. It'll be great, right? No. Here is my favorite error message in all of Python. I hope you all have your own favorites. Unbound local error cannot access local variable counter where it is not associated with a value. I know. It's but that's okay. That's why we go to therapy. So basically, what's going on here? The problem is as follows. When we assign to a variable in a function, it is right away a local variable. Python notices this at compile time, actually. Any assignment and any def to a local variable, or a variable in a function, it's automatically a local variable. So basically, here, when we define wrapper, it sees that we're assigning to counter plus equal 1, and says, oh, it's a local variable in the inner function. That's not what we want. We want it to know that we want to add to the outer function. And here we use one of the least intuitive keywords in Python, non-local counter. Now, what that tells Python is, when I assign a counter, I don't mean to create a local variable in wrapper. Rather, I mean to assign to a local variable in an outer scope. This is similar to, but distinct from, the global keyword, which says I want to assign to a global variable outside of any function. Okay, so now we're doing okay. Now, every time I call it, it's going to go up by 1. So counter is 1 for slow add, and 1 for slow mul. Counter is 2 for slow add, and 2 for slow mul. And then 3 for slow add, and 3 for slow mul. Fantastic. So this is where we see really these like closure properties, where that outer function, and this is weird, right? We called the outer function, we called count calls, it's done, it's over. It is not executing anymore, but its local variables stick around. Not only do they stick around that we can read from them, they stick around that we can assign to them and keep using them after the function is gone. Yes, please.
Other than decorators like this, have you ever used non-local sound? First time I've ever seen it.
Oh, yeah. I mean, look, it's always going to be with inner functions. And inner functions are really useful. Decorators are a sort of classic case of where you're going to use them, but it's not the only place. So there is in the operator module, there's this fantastic function called, oh, now I'm forgetting. Anyway, it does square brackets. And it basically is like the function version of square brackets. And you can implement that, like I sometimes do that with courses. I won't like torture you folks. Sometimes do with courses where I have them implement that, item getter, and you can re-implement item getter very easily with an inner function. You're not necessarily going to use non-local there, but inner functions are more useful than you might think. And when you want to use the outer function storage, non-local is basically crucial. Yeah, please, in the back. So.
Would it be poor practice to have an inner variable with the same name as the outer variable there?
I don't think you can.
Okay.
I don't think you can. It's sort of like if you try to have, if you use the global keyword on a parameter, Python's like, whoa, you can't do that. Like, you got to choose. It's either local or global.
Okay, so the problem wasn't that you were trying to add to a variable.
Well,
Have a value in wrapper.
the error before, oh, I guess I got rid of that. Oops, sorry. The error before, hold on a second. Let's just do a little Jupyter surgery here. There we go. So now we get the error. Oh, I thought we got the error. We should get the error now, right? Oh, I defined, okay, right. Oh, that's right. Oh, I didn't fit it. I didn't fix it yet, that's why. Hold on, let's just do this here. Oh, now I'm like undoing too much. Heaven help us. Okay, hold on a second. Let's just do it this way. Kablam, kablam, and we get rid of non-local. There we go. That's all I needed to do. So now we should get the error. Oh, come on, don't do this to me.
But you would still get the error if you were setting the variable to, instead of plus equals 1, just counter equals 1.
No. It's because you're retrieving it. Hold on a second. Let me just figure out like why this is not dying with a terrible error. I could restart the kernel. I don't think that's a problem, but sure. I'll restart the kernel.
Isn't that more infuriating?
Oh, there we go. Now I get the error. Oh, it was just like being really slow. What'd you say?
I was like, isn't that more infuriating? You're trying to break it and it won't break.
Yeah, I know. Like there was this cartoon I saw years ago that said half the time programmers wonder why their code does not work, and the other half they wonder why it does work. I was like, that's me. I'm so there. All right. So now, non-local to the rescue. So hold on. Just put it in here, and then we'll go back and answer your question. So if I say here non-local counter, then we should be fine. Indeed. Oh no, name error. Oh, because time is not defined. What is time anyway? Import. Time. Okay. So then, oh, random is not. I knew there was something else I needed to import. Import random. Voila. Okay. So I go up here. So what was the problem? The problem was not that I was assigning the counter. The problem is I was using counter plus equal 1, and that's the equivalent of saying counter equals counter plus 1. So at compile time, Python sees that we're assigning a counter. It's like, oh, you're assigning to it, so it's a local variable. But at runtime, the first thing happens, remember, an assignment, first the right side, then the left side. So the right side says, I need the value of counter. Is counter local? Yes. What is the value of counter? Uh-oh. And it dies there a horrible, awful death. Okay, so we use non-local, and then we're fine. And this technique of using the outer function as like private storage for our decorator is pretty cool, I think. Please.
So when would that counter go back to 0?
Never.
Like, how does it persist?
Oh, well, persist because, here, you know what? Let's put this in the Python tutor. Hope to God it works. All right, so let's edit this code. Voila. Okay, so now I'm going to visualize. Oh, import time, because it doesn't do time. Fine. Oh, you know, but I don't really need time here, do I? Oh, I'll just get rid of sleep, which is good for everyone. We'll just be a little hyper, but yeah. Oh, wait, I didn't want to get rid of it here. Hold on, put it back in there. Goodness, okay. Now we're fine there, and now I'll put it back in here. Oh, I know why, because I need to edit here. Got it. Get rid of this thing, get rid of this thing, get rid of this thing, and get rid of this thing. Now it's not so slow add and slow mul, but you know, not the first to pad its resume. Okay. So we're going to define count calls. That's our decorator function. Okay? I'm going to make this a little smaller. I'm sorry, just like otherwise it's a little out of control. And now we're going to define slow add with a count calls decorator. So we're going to define slow add. So now count calls, right? We're calling count calls. It's going to define counter. It's going to define wrapper, returns wrapper. So now look what happens. We now have, wait, I guess I have to go one more. So we now have slow add, the global variable, referring to wrapper. Wrapper refers back to the stack frame in which count calls was defined. It has func, our function, wrapper, this, counter, and the return value. I guess we get rid of the return value. Oh no, we have to have that. So basically, this counter here is available to us, and we can update it, but it's never going to go back to 0. Each of our instances of wrapper, by the way, let me just move forward here, will have its own counter that is updated independently. Right? So counter for this, for slow add, now is 1, but for slow mul is 0. You could, I guess, in theory, have some argument that you pass to the function that then tells the decorator to reset it. It'll be a little weird, but you could totally do it. Yeah, you had a question?
I was going to say, if you want to reach in and do that,
So this is one of the rare cases in Python where you just don't have access to that. Right? The only way to access that function, the formally running stack frames function, is through the wrapper. You might be able to like navigate through Python's innards and its stack frames and do something, and I'm sure you can. But then, like, you know, you're playing with fire, nuclear fire. Yeah.
It's not immediately obvious to me how the counter is understanding that this function is separate from this function. Like, would it work if I was calling slow add a lot more than slow mul? Is it?
Oh yeah, yeah, no. So let's do slow. Good question. So if I do like slow add, and slow mul, right? So basically, it's going to count slow add 1, 2, 3, and slow mul will be 1.
But like, how is it doing that? I'm not entirely able to.
Sure, because every time, let me go back to the Python tutor here and maybe make some sense of this spaghetti. So when we call the decorator, when we call count calls, when we use count calls, it is then here's count calls from slow add, and here's count calls from slow mul. Each of them has its own local variable counter. And so it's totally separate from the other one. There's no leakage between them. And so every time you decorate a function, you get a new, for lack of a better term, instance of the decorator with its own local storage that then sticks around. Excellent. Yes, please.
Like this property that the counter is like surviving multiple calls of like say slow add. Is this like specific for decorators, or can we do this for like if we say in this case don't use the decorator, use the earlier syntax of defining a equal to wrapper a, will it still work, or is this like, because usually like the variables like die after the return.
Yes.
So in this case, like, how is it surviving?
Okay, so the question is like, how is this surviving across calls? Normally, if I have a local variable, so my function starts up, the local variable is defined, it gets its values, it does the thing, and it's over. And when a function exits, all of its local variables are destroyed. Okay? Here, though, because basically Python notices that the inner function is still referring to those variables in the outer scope. So it doesn't let the outer stack frame go away. And so it persists even though you would not expect that to be the case.
So in this case, like if you remove that counter plus equal to 1 from the wrapper function, then it will like destroy the counter.
So the question is, if we were to get rid of counter plus equal 1, would it destroy that? And the answer is no, because it still has func. The inner function wrapper is still referring to func in the outside. But you're right that if I had an inner function that referred to one variable and I got rid of that one variable, then Python would notice and it would get rid of that connection. You're right. Yeah, please.
If you're using ancient technology and you're running out of space, do these things, how do they die? Like, how do you get that space back after you do it?
So the question is, like, he's basically figured out, wait a second, this means that every time I use a decorator, I'm like using more memory. And if I do this a lot, I could be using a lot more memory. This is sponsored by RAM companies. No, so basically, what do we do about that? And so the dirty secret in Python is that global variables never go away. And they are always referring to the memory that they used. And functions are typically global variables. So here we have basically a function stack frame that's just adding to the party there. I guess in theory, if you were to del the function that had been decorated, then you would get that memory back. Hopefully it's not that much storage, right? Like as things go, this is pretty small usually, but it could be huge. I'll give you, by the way, so I gave a talk a few years ago about, what's it called? Refs, weak refs. And I talked about it, and basically one of the uses for weak references in Python is to create a dictionary where if the object goes away, then it removes that entry in the dictionary, in the dict, because otherwise it would just fill up with too much stuff. So there are like solutions in the Python world for this. They're imperfect for this sort of thing, but it is trying to address these sorts of problems. Other questions? Yes, please.
Is counter atomic in any chance? Like, what if I decorate a function and then I want to pass through like a multi-threaded thingy?
Whoa. I don't know. I mean, let's break it down. So the question was, is counter like atomic, or is the action on counter atomic? So the answer to that is no. Plus equal is definitely not atomic because it's first doing, well, I mean, it could be if you're using dunder I add, but even if you are, it's not necessarily atomic inside of there. So you can't bet on any of that being atomic. So actually, that's an easy answer. What will happen? Who knows? That's the fun, right, of multi-threading. So yeah, you would want to like put something around that to make sure it wasn't messing up.
Right. So like a follow-up question to that is like this behavior makes a lot of sense, but because like if that's the case, using this behavior to count how many times the function is invoked, is that just accurate behavior? Like, is that something that we should be doing, or like, what would be the case where this behavior is suited for?
Look, using the outer function for storage is, I think, a very useful technique. We're going to see some more examples of how we can do that and where we can do that. This is like a simple technique, but there's nothing wrong with it. I mean, how often do you want to know how often a function has been called? I don't know. It could be, I'm really speculating here without any knowledge, it could be that some like profilers do this sort of thing. For example, I'm trying to remember what it's called, PySnooper. Right, it works based on a decorator, and then it prints all sorts of information about the function it's profiling. I would not be surprised if it uses these sorts of outer variables to keep track of all sorts of calls of things. Okay, sure. Other questions or comments? Okay, let's, so we have a break coming up in 8 minutes. So here's what we're going to do. I'm going to show you an example of where we can do this like in a more sort of interesting, sophisticated way. Then we're going to take the break. Then we're going to come back and we're going to do an exercise using this stuff and then go deeper and deeper into it. So let's see. So what I want to do is, I'm going to grab slow add and slow mul. Oh, and I guess okay. So let's talk about memoization. So this is an old technique for caching. The idea is that every time we call a function, we want to check the arguments passed to the function. And so if the arguments haven't been seen before, then we run the function and cache the result. If the arguments have been seen before, then just grab the results from the cache and return them. Now, obviously, this only works for functions that are sort of pure functions that are mathematical. So you can think of like SHA-1 or MD5 or something like that, right? Like, you know, polling a website or an API, probably not a good idea to cache this way, unless your boss is only checking how fast things run, in which case, go for it. So how can we do this? Well, I'm going to say here, something like this. I'm going to say here, memoize. That's what I'm going to call my decorator. And then I'm going to, like sleep and so forth, I'm going to say slow add of 2 and 3, slow add of 2 and 3, slow add of, like, you know, well, we'll then do slow add of 3 and 4. And I'll say slow mul of this and this and this, say 1 and 2. OK, what is my memoize going to look like? Oops. Well, I can say here, def memoize, not memorize, memoize of func. I'm going to say def wrapper splat args. And then what? Well, let's call the function. I'm going to say value equals func of args, say return value, return wrapper. And I'm going to say here, print actually calling func under name with args. Put a little tab there. And here I'm going to say, well, we can just do that. So here it's going to say actually calling. We see actually calling, actually calling, actually calling. It's taking a while because it's doing the whole slow args thing. Fine. So we are actually calling our functions many, many times, even though things repeat. So now I'm going to do some caching. So what do I want to do? Well, I can use a dictionary for my cache, right? Because a dictionary, keys, values, the keys can be a tuple, and the tuple, splat args, perfection. I mean, it doesn't always work, but it's like pretty close. And I'm going to put it in the outer function. So I'm going to say here, cache equals a dictionary. And now I can say, if args not in cache, then I'm going to do this, and then I'm going to say here, cache of args equals func of args. Right? So basically, if it's not in the cache, I'm really going to call the function, and then we're always going to return cache of args, because by the time we get here, we know that we now have it. And with just that, it doesn't work. Well, you know, equal sign. It's such a like oddity in Python that we have to tell it we want to assign things, but fine. And look at this. Slow add with 2 and 3, we have 5, but here it didn't even go to the function. It didn't run the function. This is an example of where the decorator basically says, oh, you don't need to call that. I'll give you a result. Now, it happens to be the right result that it cached from before. And notice now we get to slow add. Oh, this is a new set of arguments, so we'll have to call it. Slow mul with 4 and 5, right? And by the way, I didn't actually repeat any arguments here, but these are totally separate. Like we saw before, the counters are separate, so the caches are separate. So if I call, in fact, if I call like slow mul with 2 and 3, and I call slow mul again with 2 and 3, it will not be cached the first time, and it will be cached the second time. Right? So it actually called slow mul with 2 and 3 because it is a totally different function and a totally different cache. Now, by the way, this is an example of where things will fill up over time. Right? You call enough functions, you got enough arguments, it's going to fill up. This is why there is something in Python in the functools module called LRU cache. Least recently used cache, I think it is. Yeah, and basically it does this more or less, but it checks how many elements you have in the dictionary, and it chucks the last one, like the oldest ones, so that you'll never go over like too many. Right? Because someone realized maybe that's not the best idea. Questions or comments about this? Oh yeah, please.
Why didn't you have to mark cache as non-local?
Beautiful, beautiful. So here is the thing. We need non-local when we assign to a variable. If I had said cache equals blah, then I would need it. But because I'm saying cache square brackets equals, that's a totally separate kettle of fish. I'm mutating an existing value. I'm not assigned to a variable, and thus I don't need it. But that's very, very good noticing there. Yeah, please.
When you do use non-local, if you've got
the first one that it finds, like, so it'll go up and up and up, bubble up as many sort of levels as you need until it finds the name that you're looking for, or doesn't. But if you have it in if you have the same name in multiple levels, heaven help you.
What if you call cache non-local?
So you can't, that would be fantastic. Unfortunately, in multiple ways, non-local is a keyword and you can't assign to it.
No, sorry. What I meant like after def wrapper.
I thought you were trying to like let's break Python, and I love that. So actually it wouldn't make any difference whatsoever. It wouldn't hurt, but it wouldn't help. Yeah, please.
In previous examples, when, like for instance, in our with lines example where we weren't using the decorator, if we had a variable outside of the wrapper, would it work the same way that it's working with the decorator, where it persists?
Yeah, so the question is, would this work the same way if it were not in a decorator? And yes, these are properties not of decorator. Decorator, the only part that's specific to decorator of anything we're doing today is that at syntax. Everything else is just sort of regular old inner functions for some value of regular. So all of these are just properties of inner functions and of closures that happen to fit really nicely with what we want to do with decorators. Okay, I think it's time for a break. Rodrigo, am I right on the timing there? Woohoo! So we're going to take half an hour, and when we come back, we are going to do an exercise with the outer function stuff. We're going to talk about modifying inputs and outputs, and then we're going to talk about decorators that take arguments. And I think we'll even have time to talk about nested decorators and a little bit on classes. All right, so we'll come back here at 3:30. Enjoy the break. Let me see where we are. That's right, okay. Okay, so before the break, we were talking about how we can use the outer function for storage and different things we can do with it. So what I want to do now is an exercise to play with this, right? So we had the counter for how often, how many times a function had been run, and then we looked at memoize as well. And I just want to sort of point to the difference between these two, because they are different in a way that one or two of you asked me about. When I'm assigning to that counter, I'm assigning to a variable. I am saying counter equals something else, and thus I must use non-local because I'm changing the value. I'm assigning to a variable in the outer scope. By contrast, if I just have a dictionary in the outer scope, and I'm updating an existing, or even adding a new key-value pair, it's the same dictionary, it just has different pairs in it. Then I don't need to say non-local. It doesn't hurt, but it doesn't necessarily help because I'm not saying cache equals something. I'm saying cache square brackets equals something. All right, but both of these are totally legitimate things to do to take advantage of the outer scope. Right? Sometimes I'll want to have something larger, sometimes smaller, and so forth. Let me actually stop here. Anyone have questions about what we've done so far, like percolated up during the break? Other than why me? Okay. What have I done to deserve being here? All right. So let's do an exercise then. And we're going to say here once per minute. I'll even put it like that, once per minute. And so what I want you to do is write a decorator once per minute that ensures a function can only run once in any 60-second period. So every time the function starts, it resets the counter, or it checks to make sure that at least 60 seconds have passed. If 60 seconds haven't passed since the last run, we should raise an exception. You can make it a custom exception, but if you just want to use a built-in value, well, if you just want to use something built-in, that's fine too. If they have passed, then reset the counter to the most recent start time. And in terms of hints, first of all, use time.time to get the current Unix time, number of seconds since January 1st, 1970. Yeah, and then I would suggest use slow add. Well, you don't even have to make it slow; it doesn't really matter. Whatever, you'll sort of figure that out. Okay, so give that a shot. If you have questions, let me know. I'm happy to answer them. We'll go over together in a few minutes, and then we'll dive deeper into some other decoratory things. Let's take a look at this, see what we can do with it. So I'm going to go back. Whoa! I'm going to go back and find our slow add and slow mul. They will come in handy. So I'm going to say here, then let's do once per minute. Once per minute. Okay. So we got that, and now I'm going to say slow add and slow mul. Well, slow add, slow mul. We'll say slow add, slow mul again. Okay. Obviously, right now, it's not going to work because once per minute is not defined. So let's do that. Say def once per minute. Func, because that's always going to be. Def wrapper, splat args. And now what? Well, let's start off with, like as usual, just making it work. Value equals func of splat args. Oops, come back. Now I say here, return value, return wrapper. So if we do this, everything works great, right? Except for the decorator part. But that's a small matter of programming. So now what do we want to do? Well, I'm going to say here import time to find out what time it is. And I can say here now current time equals time.time. Let's find out what time it is. And now I want to compare it with when we last ran things. Well, when did we last run things? We haven't stored that anywhere. I'm going to put that in the outer function. I have to put it in the outer function because otherwise it's going to go away each time, right? I got to keep track of it. So I'm going to say last ran at. I'm going to start it at 0. This started way back in 1970. Well, that's a long-running program. And so now what I'm going to do is I'm going to say if current time minus last ran at is less than 60, let's even create our own class called to often error. Exception, pass. This is, by the way, for those who don't know, how we can create our own exception class. The whole point of creating an exception class is not to add functionality, it's to add semantic depth. So I just create a new class, I have it inherit from exception, and pass. It does nothing. But now I can raise that exception and treat it differently from so many other things. So now I can say if current time minus last ran at is less than 60, raise, oops, that's not it at all. Oh no, come back. Well, end of the tutorial. Raise called to often error, right? Too soon. Otherwise, what am I going to do? Well, first of all, I'm going to say here, last ran at equals current time. But of course, if I do this, I'm going to get our unbound local error again. Why? Because I assigned to last ran at inside of this inner function. But before assigning to it, I read from it. So Python knows that it's a local variable, and yet it doesn't have a value for it. So what I have to do is say, no, this is actually non-local last ran at, meaning when you want to read from it and assign to it, don't look for a local variable, look in the outer scope, in the enclosing function scope. And so now, let's see what happens. Slow add should work, slow mul should work, and then called to often error. Yay us. Okay? So this is how a decorator can start to be more sophisticated, and this is only possible, it's not only possible, but it's normal in any sort of sense, using the outer scope. Could I have used a local variable for this? No. Could I have used a global variable for this? Yes. I could have like a global dictionary, but heaven help us, right? Then it's going to be like incredibly unmanageable. This keeps every single decorated function's sort of a state there tied to the outer function. So it's not going to mess with anyone else. Questions, comments, thoughts about this? Stunned silence. Okay. That's the way I like it. Oh, excellent, excellent. Show the what? Oh, yeah, the hints. Time started in 1970, because that's when I was born. Before that, it was irrelevant. There are ways, you can't use Unix time for that. You have to use other techniques. like Windows time. No, please, please. Okay, so let's now, yeah, we can do this first. So what I want to do now is talk about modifying inputs and outputs. So basically, our decorator, when we write a decorator, we have two opportunities to do something. So one of them is when we define the function and it's originally decorated, that is done by the outer function. And again, when we run the function and it's meaning that the inner wrapper function is invoked. So this means that wrapper gets the arguments we wanted to pass to the original function. And it then invokes, or not, the original function. It can use this opportunity to filter or modify the arguments that we pass, and also filter or modify any results that we return. Now, we've already seen a simple version of this before when we saw with lines and we saw shouter. In both cases, the function returned output, and we were like, no, we're going to package that output up into something else. But we can be way more sophisticated about that. So for example, how about this? What if I say here, let's write a, okay, let's do something a little silly, and then we'll do something, and I'll give you an exercise that's a little less silly. Just like this. All right, let's write a function, or let's write a decorator that takes all of the arguments passed to a function and assumes that they are all integers. Okay? It only passes along those integers that are odd. Okay, so if I now call, so for example, if I say def my sum splat numbers, total equals 0, and for one number in numbers, total plus equal one number. So if I say now, return total. So normally, if I could do this. I could say here, my sum of 2, 3, 4, 5, right? And this should return then 14, because it's adding 2 and 3 and 4 and 5. But if I have my decorator in place, with my only odds in place, we'll get, we'll have 3 plus 5, 8. That is 3 plus 5. So let's see how we could do that. I'm going to do this again. And I'm going to say here, @ only odds. By the way, I just have to have this incredibly random aside. But anyway, so I live in Israel. And in Israel, of course, we don't call it an @ sign. You know what it's called there? It's called strudel. Because if you look at it from the side, it looks like it all wrapped up. Anyway. So I keep almost saying it, but no. All right. So if I now say def only odds func, I say def wrapper splat args. And let's once again sort of pretend that we don't want to do anything. So values equals func of args, return, or value, and then return wrapper. Okay, and it still says 14. But now let's do something about this. So let's think once again what we have here. So when I say splat args here, that means I want to get a bunch of arguments. I don't know how many, a bunch of positional arguments I should add. Keyword arguments, which are of this form name equals value with that equal sign, those are ignored by splat args. We're ignoring them for now. And then what we're doing, that becomes a tuple. So args will be a tuple inside of wrapper. We then say, I want to call func, and I want to unroll that tuple, make it into individual arguments. So func is not getting a tuple. It's getting all the elements of that tuple. Again, I think mentioned before, I think of it as removing the parentheses and keeping the stuff with the commas. So args is a tuple. And I have to somehow, so how can I do this? Well, I could do something like this. I could say here, right, odd numbers equals an empty list for one item in args if one item modulo 2 equals 1. And yes, I could just say one item modulo 2, but I'd like to be a little more explicit. then I can say odd numbers append one item. And so now what I've done, and we will tighten this up in a little bit, now I've got this list, and I've added things to this list, and so now can I say odd numbers here? No, of course not, I can't do that. Because again, the function is not expecting to get a list of numbers, it's expecting to get the numbers themselves. So what can I do? Cry. No, I can put here a star, and now it works, and now I get 8. Because basically odd numbers, what is it? It's a list. We put it in func, but because we put the splat before it, it gets rid of the square brackets, and now we're passing those arguments. Now this is fine, but I think we can improve this code a little bit. All right, let's tighten up the code a bit.
So the splat automatically makes that list into a tuple, or it's not quite here?
No, it's not doing a tuple. It's turning to arguments. It's turning to an argument list. So it's not, it's like it takes a tuple and removes that round parentheses, takes the list and removes the square brackets. You can even do it if you put a dictionary there, you get the keys. But only the keys, because that's what you get when you iterate over a dictionary. So, well, what can I do here? Well, let's think about it. I have args, which is a tuple, which is iterable. I want the elements of args as they are, except minus the even numbers. So I have an iterable and I want an iterable. This is a job for comprehensions. So that's, they're like, that's enough to do decorators. So I can say odd numbers equals, I'll say one item, I'll even say one arg, for one arg in args, where if one arg modulo 2 equals 1. And this creates exactly the same list, and I get exactly the same results. But why should I write so much code? I mean, come on, really, guys. Let's say I've cut up a bit too much. What if I just go here, grab this thing, get rid of the whole odd numbers thing, and just say that? You know what we call this? Job security. Right? So basically, I'm creating a list. It's an anonymous list. I'm not assigning it to any variable, but it is still a list. And because it's in a function call, and I put the star before it, that removes the parentheses, the brackets, and now I'm just passing those arguments, and it gives me the right answer. Okay? So this is the sort of thing that we can do with inputs, with outputs also, but especially with inputs, so we can filter them through some sort of mechanism. We can also transform them if we want. Right? I could say, I want to turn all these into strings. I want to turn them all to ints. You name it. OK, questions or comments? And then we're going to try an exercise based on this. OK. So, exercise, I call this only ints. It's similar. Right? So now, write a decorator that ensures that only integers will be passed to the underlying function. Okay, and as a hint, right, don't ever use type of x equals int in your code. Rather use isInstance x int to check. And the reason is basically that isInstance also checks subclasses and so forth. I mean, for int it's a little silly perhaps, but basically this is considered to be less nice than that because that handles subclasses and so forth. But it will still work. All right, so the idea is basically if I now say something like, as an example, if I say here like, def, yeah, I can do my sum. So if I say like, let's just do this. I should be able to call my sum, let's do this, my sum of 10, 15, hello, 20, 30, goodbye, right? And it'll work just fine. It'll give me, 25, 45, 75, returning 75, and not giving me any exception. All right, so see what you can do on that front, and we will go over it together. All right, so obviously if I do this without the decorator, it's just going to blow up on me because it's going to say, OK, 10 plus 0, that's 10, plus another 15, that's 25, plus hello, haha, no way, right? And it even says here, unsupported operand type for plus equal int and stir. So what are we going to do about this? Well, I'm going to say here, only ints. And I'm going to say def, only ints, func, def wrapper, splat args. And now what? Well, it's going to be very similar to what I did before, but my test is going to be different. But I'm going to, again, break it up so we can see it more easily. Value equals func of splat args, return value, return wrapper. Okay, so once again, it gives me the error because I didn't actually filter anything. And now what I'm going to do is I'm going to say func of splat args. I'm going to say here, right, so ints equals, and we'll say here, one arg for one arg in args, if is instance, one arg int. Okay, and now I can just say here, splat of ints. And look at that, I get 75. It worked just fine. And I could, of course, put this whole thing there in the parentheses. I'm going to do that right now, but that's the whole idea, that I create this list. I could even use a generator expression, but let's not go totally crazy. And it works just fine. So this is a way for me to sort of protect my function in some way. Now, it's not type checking in a really serious way, but you can see how we can sort of set up all sorts of guardrails there. And like before we did the only once per minute, and now we're doing only ints. You can imagine, again, it's not perfect, it's not hermetic, but you can use it for all sorts of security things, all sorts of checking of things. I only want certain users of certain, at certain times of day. You can make it like a time lock on a safe in a bank. I don't know if they still do that. They used to, right? Like, only at certain times can we run this function. Only certain people can run this function. Only in certain circumstances can we run this function, and so on and so forth. Questions or comments? Yeah, please.
Is there any reason why you want to put the decorator on a decorator with maybe the time one?
Oh, you could definitely do that. Give it a few minutes. That's known as an interior decorator. Okay, so I gotta remember that one. Okay, so let's then let's talk about decorators. Actually, I just want to show you one thing that I sort of wanted to stick in somewhere. It's not going to take long, about decorators. So I've got my sum, and it has been decorated. And I'm like, in Jupyter, and I love using help in Jupyter. So I'll be like, hey, give me help on len. I don't do that very often, but oh, help on len, fine. And I say, help on my sum. Tell me about my sum. And it says, oh yes, that's wrapper, it takes splat args. I'm like, wait, what? But that's, of course, true. It's true because when I use the @ symbol there, when I use the decorator, it reassigned my sum to point to wrapper, which we got back from the inner function. Well, it is the inner function. So what can I do about this? And it turns out there is actually a great solution. Yeah, exactly. How can we avoid that situation? Easy. We use a decorator. I'm going to say here, import functools. And then I'm going to apply functools wraps of func to wrapper. I know. So basically what I'm doing is when I define wrapper here, I'm like, wait, I want to hijack the definition of wrapper. And what does functool wraps do? It rewrites the name and rewrites the signature so that now when I say help on wrapper, it basically, my sum, it pulls out the original name and reassigns it and pulls out the original signature and reassigns it. So we now get also the docstring. If we had a docstring in our function, we don't want wrapper's docstring, we want our function's docstring, and wraps does that. Yes, please. I was hoping no one was going to ask me. So I'll tell you the honest truth. What it does for defining, redefining the name, that's easy because every function has a dunder name attribute and it's there. What does it really do? I haven't checked into it, and I've often puzzled about it, and I realized as the words were coming out of my mouth before, I don't really know how it works. But because normally I would think that help basically looks at the code object, which says, like CO var name, CO and CO arg count and that sort of thing and pulls it together. But it can't rewrite the code object because that would be bad. So it must be doing something else. I'm not quite sure what. Yeah, I don't know. Now it's really like eating at me. Now I'm gonna have to like look this up tonight. Okay. Other difficult questions? Okay. So, thing is, what if I want my decorator to take arguments? Right? So, for example, earlier, much earlier, we wrote a decorator that times the running of a function. I asked you to write the output into a file called, what did I say, timing.txt? I think that's where we put it. Wouldn't it be nice if we could configure that when we invoke our decorator? So let's go back and grab that decorator there and think about what we're going to do with it. Where did I put it? It's like up here with lines. Oh, there we go. Perfect. I got this. Okay, good. So let's think about, again, what's going on here. When I say at time func, what's really happening? It's saying slow add equals time func of slow add. Now what I want to do is I want to say time func of, let's call it timing, timing2.txt. I want to be able to pass it an argument. So what that means then is I'm no longer going to be calling time func on slow add. Instead, I'm going to be calling this. I'm going to call time func with an argument. That is going to return a function. That function will be applied to slow add. That will return a function. And that function will be assigned back to slow add. That's right, friends. In order, let's do it this way. In order to have a decorator take an argument, we need 3 levels of function. It does not go beyond that, by the way. Okay? So the outer function is our decorator, and now takes the argument that the user passes in the at expression. The middle function is takes func as an argument. It is passed the function that we are decorating. And the inner function, wrapper, remains as before. So you can think about it, think of this as breaking the outer function into 2 pieces. One that takes the argument, and the second that takes the function. Okay, so how are we going to do this? I'm going to say here def time func, and it's now going to take, I'm going to say def time func file name. And then I'm going to say def middle func. And then I'm going to say here, put all this stuff in there, there. Actually, no, this has to go there. So middle takes the function, and now we have wrapper doing its thing. Wrapper will return value. Middle will return wrapper. And time func will return middle. All I have to do now is say, instead of timing.txt, I say file name. And as before, someone was asking me this before, thanks to the LEGB rule, thanks to the enclosing function rule, it'll look for file name in wrapper, not find it. It'll look for it in middle, not find it. It'll look for it in func and find it, and then we're golden. So I can do this now, and I can then say timing of that, and I can say here timing3.txt. And so now, if I call these, it's going to take a few moments here, 5 to 20. So now if I look at cat of timing2.txt, slow add, and cat of timing3.txt, slow mull. Pretty snazzy. So, and this is a purely almost cut and paste logical extension of what we did before. And it's simply because this syntax here, right? So whatever is after the @ sign, that is what is going to be applied to the function, the decorated function. So normally it would just be a function that directly does it. But now we're calling a function that returns a function that calls a function that returns a function. So now we have 4 functions running around: the original decorated function, and then timefunc and middle and wrapper. By the way, a very, very large number of decorators out, shall we say, in the wild, take arguments, right? So PyTest, Flask, Django, all sorts of other things, they take arguments, and this is how they do it. Okay, properties do that as well, to some degree. Yes, please.
How come you can't configure it in such a way where time function is two arguments to found in?
So we can't, like it just wouldn't work that way because everything needs to be returning functions. It certainly, I guess, would have been a reasonable design decision for like the implementers of this. There might be a reason why they decided not to. I think part of the issue is that we've got this like extra step in here that needs to be providing a function. The question was like, why can't we just like provide 2 arguments? So that's not available to us. But maybe back in the days when they implemented decorators, they could have done it that way. Look, I can imagine a world, now that you're saying it, I can imagine a world in which like the outer function would have one mandatory argument, the decorated function, and then take splat args and take everything else. Maybe in Python 4. Like obscene language there, I know, but like, yeah. Other questions? Okay. Let's then try this as an exercise. So let's say only these types. So I want you to rewrite the only ints decorator such that it takes an argument. Actually, it takes any number of arguments, the types that you will allow to be filtered, to be passed along to the underlying function. Marked down, there we go, to pass along to the underlying function. So if someone uses, let's say here, at only these types of int and float, then both int and float will go through and others won't. Okay? So see what you can do with that, and we'll go over it together, and then we'll play with a few more things. So here's what I'm going to do. I'm going to go back to only ints from before. Let's just get the one without the wraps in there. Okay. Okay. So we've got only ints from before, right? And it worked. It worked this way. What if, though, I say here 3.5? If I do that, is that going to be included? No, it's not, because it's a float. So I want to now change it so I can say only ints. Let's say here just int for starters. Now, if I just do this, if I add this call to only ints, and that's what it is, it's a function call, suddenly everything's going to break, right? It's going to say int object is not callable. So we've got to add another layer here. So I'm going to say def only ints of, we're going to say here, splat args. And then we're going to say def middle func. And then we're going to indent all of these guys. Oops, not that much. And we're going to say here, return middle. So now, having done that, we should be OK with at least, well, it's still going to only do ints, but it's going to be something. OK, so it's not breaking. We've at least managed to get to the point where we can call it passing int. That gets in there, and it's all working. However, this obviously is not so good. We don't want int. We want, oh, I'm sorry. Yes, please.
Good question. Is it common practice to call the middle function middle, or is there
I think I made that up. I can't remember if I've seen someone else call it that or if I've just done that. I don't know. But I encourage you all to do that and then say what a brilliant idea it was. So I'm now going to say, and this is kind of a cool trick, I can say is instance args. That's right. You can pass a tuple there to is instance, and it'll check if any of those things work. So you don't have to do ors and all that other stuff. And so now, and here I'm going to say here like We say like, acceptable args. I'll say here of acceptable args. So if now I do this with int, arg2 must be a type, arg2 must be a type, a tuple of types or a union. Didn't I pass it a tuple of types? Oh, one arg and args. Oh, haha. One. Wait, what am I doing twice? Hold on. Oh, yes, that. Other than that, Mrs. Lincoln. So let's say here, acceptable types. That's probably a smarter thing to call it anyway. And we'll say here then, acceptable types. Thank you. Voila. Now that worked. And then if I say int, comma, float, ho-ho, success. Right? So basically, I'm now able to say any types I want, just pass them as args. Those are passed to only ints. Only ints then defines middle and returns it. That is applied to this and decorates it. And then we replaced it with wrapper, which is called. And so you can see here that multi-layer enclosed function variable. That here, right, we are getting func, so we are calling the function from the immediately enclosing function, and we're using acceptable args. We're using acceptable types from the outer function. Okay. So now let's get to the question that was asked before, which is, can we stack decorators? And the answer is yes. Do you want to is another question. No, it's actually kind of useful. And again, you have to remember, there's no reason why we can't, because at the end of the day, all we're doing is passing a function to another function as an argument. So we're sort of, for lack of a better term, wrapping it all up together there. So let's take two of the decorators we've used so far. So let's actually take only ints here, which we just used. So I'm going to do that here. Right? So this works. We just saw it work. And now what happens if I also say here time func of, and now I have to add that there as well. So let's say here, my sum timing.txt. Not only does it work, right? Cat my sum timing. Oops. Look at that. Well, wrapper because I didn't use wraps there. Fine. So what's going on? How is this actually working? Well, first thing that happens is our function is defined. Okay. As soon as the function is defined, what happens? Then Python comes in and it says, okay, my sum equals only ints, int and float, of my sum. So now my sum is the wrapper of only ints. And then we say my sum equals time func, we'll just say, file name here, of my sum. We are decorating it twice, but there's no reason, like you can call a function, you can call one function and then a second function on values. So it's weird, like you have the original function, around it you have only ints, and around that you have time func. And so when we are decorating these functions, or this function, it's going from the inside out. But then when we call it, it goes from the outside in, because that outer layer wrapper is first running, then the middle layer wrapper is running, and then our original function is running. But there's no reason you can't do this, as we see here, right? It did both of them. It both kept only ints and floats, and it wrote our timing to that file.
In this case, does it matter, right? Switch between it wouldn't matter?
Yes and no, right? So it will work if you do this in either direction. But for example, the fact that we're doing timing there, right? The timing might be affected. Do we want to time the original function, or do we want to time the filtering that's being done? So it does get a little tricky there. And you can do this, as many layers as you want. Although again, at a certain point, you want to retain your sanity. Or so I've heard. Questions, comments? Yeah, please.
So the timing function, the function name is now wrapper.
Yes, so if we go back here, the reason for that is, so I didn't use the functools wraps on it to rewrite the name. So it was like, I need to do that. If you do that consistently on all of your decorators, then you don't end up with this at all. Then it like carries through all of them. So in fact here, let's do this. If we say here, fine, I'll just go back to like only, what did I use here? Only ints. Oh, I shouldn't have really called it only ints, right? That's like only these types. I even told you to do that. Only these types. Let's do this here. These types. Only ints, also int and float. These types. All right, so that should work there. Fine, good. I'm going to change this. Now let's go back and add functools wraps in there. I'm going to say here import functools, and here I'm going to say functools wraps func. So that should at least solve the problem for that. And there we go. Now we got my sum there. So at least that is doing better there, thanks to functools wraps. Okay. All right. Let me just look at my list. Yeah, I think we do like one more thing. So let's talk a little bit about decorating classes as well. Now this is rarer for sure, but it's not unheard of, not at all. So can we decorate classes? And the answer is yes, because decorators are actually not function specific. Right? We often talk about decorators as working on functions, but really they're working on any callable, where callable is an object in Python, well, that we can call, that we can put parentheses on. Typically, callables in Python are functions and classes. So really, like, I mean, and I've sometimes heard the definition that a decorator is a callable that takes a callable argument and returns a callable value. And strangely, people think this is confusing. So basically, we can, so if we decorate a class, what's going to happen? Well, so the outer decorator function is invoked at creation, at definition time. That would be when we define the class. And the inner wrapper function is invoked at invocation time, at runtime. That would be when we create a new instance. Okay, so now we've got to think about it in slightly different ways, but it's exactly the same mechanism as before. So how is this going to work? The answer is strangely. So I'm going to say here, like class, my class, say here def init self x equals x. I'll do like a def x2 self return self x times 2. I can say m1 equals my class of 10, and then print m1 of x2. I wanted more there. I can say here m2 equals my class of 20, print m2 x2. Right, so like basically I've just got the class there. So now what? Let's write a simple decorator that just like tells us what's going on. So I'm going to say here like, loud deco. So now what happens? I have to say def loud deco. Now notice, I'm going to define this as a function. Well, I guess I'll say CLS, right? I'll say print now invoking loud deco decorator. And I'm going to say def wrapper splat args print now invoking, let's do this, CLS under name, wrapper on with args equals that. And then I'm just going to say, well, now what do I have to do, right? I can say return, we can say value equals CLS of args, splat args, return value, return wrapper. There is zero difference between this decorator and what I did before as a simple decorator, except for the fact that I now am saying, oh, no, this is for a class as opposed to for a function. But this decorator will work just as fine on a function. But here now we can see, OK, how often are we invoking them? So we're invoking loud deco once. The outer function is being invoked once. When we defined our class. But each time we create an instance of my class, we see that it's being invoked there. Yeah, please.
So in Python, if you only have one method in a class, is that like a functor from C++ where it's like if you execute the class, that's executed? Is that why that works? What if you have more than one method in your class?
So I'm not sure what a functor is, because the last time I used C++ was many, many years ago, and you see what a happy person I am. But basically, when you define a class, the class's body is actually executed line by line. The best analogy I have is a class is a module without a file. So every line of the class's body is executed. Now you're saying, but that doesn't mean that the functions, the methods are executed. The def is executed to define each of the methods. So the body of the method is not executed, but the def is in order to define it, in order to attach it to the class.
So when you decorate a class, does it decorate each function?
No, it's just the class. It's not touching any of the methods inside. It's just the class object. So remember that a class object in Python, like a class is an object. It's an object of type. And so basically when we we're decorating that class object, and we're saying when we invoke the class to get a new instance back, that's when our decorator's wrapper is going to go into effect. But the methods here, they can be decorated if we want totally separately. But that would be totally separately. You could even argue that methods, the difference is not exactly true, but that the difference between a method and a function is indeed that a method goes through this rewriting of like self, whether we have self there, that you could do nowadays with a decorator. It's not done that way. It's done with a descriptor, which is a whole different kettle of fish. But like those are, like there is some like logic going on there that gives them sort of different outputs depending on the context. But decorating the class affects the class. It doesn't affect the methods in the class. Yeah, please.
So would you typically use this as like a pre-init or a post-init type of function?
Yeah, I think that like the best example of a class decorator I've seen is data classes, right? So basically what are they doing there? They're sort of hijacking the class definition. I have to assume like at definition time, looking at the, what do they call, the type hints in, I'm guessing in Dunder type hints, type annotations. It's Dunder annotations, and then based on that, making all sorts of assignments. Other than that, I haven't seen it very often, but I could just not be looking in the right places. I mean, my gut feeling is it's sort of like with functions, where if you have the same functionality you want in many places, then you can use a class decorator. And your counter-argument might be, but wait a second, we have inheritance for that. But what if you have classes that are wildly different from one another, that they shouldn't really be inheriting from a common ancestor? Then a decorator might be an appropriate thing. Yeah, please.
In this specific case, in this example, maybe not for other subclasses or whatever, but if you were to put a decorator above the init function, would it have the same effect?
No, it would be different, because that would be a function decorator. We would be decorating the Dunder init method or function. And so it would affect that method. It would not affect the class. Now, you could probably, depending on what you're doing, it might be the same thing, right? It could be that you would be doing the same thing there, but they would be different types of decorators, because if you decorate the class, again, it's a class definition time and class invocation time, meaning creating an instance. Dunder init, you'd be sort of hijacking it when it is defined and then when it is invoked. When is it invoked? Each time we have a new instance, but it is after the new instance has been created. So here's an example. One example, people, like I teach a class on design patterns for companies, and like I sort of save the worst for last in that we talk about singletons at the end. Like how can we create a singleton? And you can do it with a decorator. But that only works because you're doing a class decorator that says, hey, wait, we already have an instance. We don't want to create a new one. And so we're going to stop it when that happens. But if you were to decorate Dunder init runs after the new instance has already been created. It's just adding attributes to it. So that would be sort of too late. Other questions? Okay, so what can I do with this? Right, so basically what it comes down to is I can add attributes. Like what do we do? Like I can add attributes to a class. So I could add new methods. I could add attributes to the new instance, because each time we invoke wrapper, we're creating a new instance. So what I could do is say something like, this is new instance equals that. And I can say something like new instance dot, I don't know, created at equals time.time. Right, and now when I run through all this, oh wait, well, value is not, because I changed it, return new instance. And so now if I say, show me the vars on M1, look at that. We automatically got this created at. So if you have a whole lot of objects where you want to have like the creation time, you can do that. Right, so what I have here is I've created the new instance, and I believe this is after dunder init has run, because when you call it, like, you get back that new instance there. So all the things that dunder init was going to do, in fact, let's check that out. Check that out. If I say here now, print of vars of, let's do it this way. I'll just do this, vars of new instance. And if my guess is right, we are going to have, watch this. So we have here, now invoking loud deco decorator, now invoking wrapper, and here x10. So when I run it, we already have x defined, the attribute defined. So when we get to line 6 here, not only has the new instance been defined, but dunder init has run and added all of its attributes. So any attributes that we add here is after dunder init has done its thing. Meaning that you can then, you were asking, I think, or someone was asking over here, like you can sort of do like a post-initialization fix-up, check-up on, well, wait a second, someone passed us some really weird things. Let's roll this back a little bit. Yeah, please.
So this is actually creating two instances of the class in memory. One that didn't have that variable and one that now has the created at.
No. So this is all, so wrapper here. So let's just say here, this is invoked each time we create a new instance of our decorated class. So every time, oh, not want to do that. That's an interesting little conundrum. Okay, so class, so it's the def wrapper of splatters. So basically, when I create a new instance, when I call my class 10, that's going to then invoke this. And so then we're going to go back to the original class and invoke it. We're going to get back the new instance, and then we're going to add a new attribute to it. But it's not like we don't have multiple copies of the class running around. Yeah, that's not a problem. Yeah, Rodrigo.
Could it be helpful to show that the name my class now actually points to a function?
That's a fantastic idea. Yes. So if I now say, like, what is the type of my class? And it's indeed a function. And in fact, what is my class's dunder name? And it is wrapper. Right? We've swapped, right? We've gotten rid of our class in favor of a function. But wait, where is the original class? It's here. Our parameter CLS is referring to it. And in the same way as we're able to refer to the original function via the enclosing function's parameter, in that case func, here we're able to refer to it thanks to the enclosing function's parameter CLS. Right? And it's the fact that both functions and classes are callable that even allows us to do this sort of thing. Like the fact that I've basically replaced a class with a function sounds like madness. And yet in Python, it's like, oh yeah, just another day. Now again, how often would you want to do this? Not very, oh yeah, please, I'm sorry. Well, the subclass is not going to, I mean, at the end of the day, like the class is still there. It's just sort of inaccessible to us directly. We have to go through this decorator in order to use it. And so the fact that you then have other classes, subclasses of that class, like they are referring to it. They just sort of, I guess, have direct access to it, as it were. Just, they have indirect access to it. You could pass an argument to your decorator. Sure, that would, like in the same way, we'd have the 3-level thing, and then that would be passed to, that would be available for the classes and so forth. Yeah. Yes, please.
So how would we get the class back if we wanted to use or be able to?
Well, let's see. Let's see if we can do a little, what did someone once call it? Open heart brain surgery. So basically, if I now say, like, my class is wrapper, so I can't get to it directly from wrapper. But what I could do is say, what is the type of M1? See, M1 still believes it's an instance of class because it is. Because even though I've hijacked the name my class, it refers to wrapper. When I invoke it, I get back an instance of that. So I can say something like type of M1 and then do whatever I want. So I could say, in fact, my class equals type of M1, and so like remove the decorator, and and now if I say like, M3 equals my class of 30, and now if I do a vars of M3, it will not have the created at. It'll just have the X. Don't do this. But it's great fun. All right, yeah, please.
Can you decorate anything else aside from functions and classes?
I believe it's only them, but I would not be surprised if I'm wrong. Like those are the traditional callables. Look, you could have, I'll tell you, at the end of the day, what makes something callable? It has the dunder call method. So any object that implements dunder call is callable, and like it joins that family. How often are there objects that implement dunder call? Other than functions and classes, it's pretty rare, but you could theoretically do that. So you could like create your own class, and it returns something that has dunder call on it, and voila, now that also would be able to do that. Yes, please.
Sorry, this is getting kind of zany, but like, can you like add a dunder call method to say like the dictionary object and then decorate a dictionary or something like that?
So you can add anything to just about anything in Python, and the just about is more or less the things that, like the base classes, like the core data types that are written in C. So like you can add attributes to whatever the heck you want, except for stir, int, list, dict, and so forth. But, what if I were to say something like, okay, I've got to like think of something here. Oh, I know. Like what if I say like from collections import default dict? This might work. I'm not entirely sure. And then I say like d equals default dict of like int. Right? So now if I say, and for those of you who don't know default dict, it's fantastic, right? So I say now d of a, what is that? Oh, we're going to invoke int and we'll get 0 back. So can I say now, so if I say d parentheses, it's going to be like, you can't do that. It's not callable. But what if I say d dunder call equals, can I do that? No, it won't let you do it. It won't let you add to it because it's also like based on dictionary. So you can't set it to anything. So if I'd been a little less ridiculous and chosen something that wasn't based on something written in C, then we probably would be okay. Yeah, please.
So when do you use the splat keyword arguments instead of the splat arguments?
So there are two types of arguments in Python. Basically, when we call a function or a class, there are two ways that arguments are mapped to parameters. One of them is positionally, based on the location, and the other is keyword, based on the name-value pairs. You can, in everything we did today, use the double splat kwargs, which will be for keyword arguments instead, and often you'll use both of them. It's just like some of the examples here get messed up if you use double splat kwargs, so I conveniently ignored them. All right, folks. Any last questions before we wrap up? Okay, well, I don't know about you. I had a lot of fun. I hope you enjoyed. I hope you learned a lot. And I hope to see you around the rest of PyCon. Have a great conference. Oh, yes. Oh, the notebook will be around forever. So, like, I mean, like, until GitHub goes under or something. Not that I'm hoping for that. Yes. Thank you. Thank you. So I'll tell you, a few years ago, I went to the Jupyter forum, and I said, listen, folks, I have this problem. And I described it, and this guy was like, oh, you should use this package I wrote called git auto push. I was like, oh my God, it changed my life. Literally a week ago, less than that, Rodrigo, who's in the back here, he was like, I wrote this script to do something. I was like, why don't you use git auto push? And the guy didn't remember us having this conversation. He was like, I can't believe someone's using my package. And like, totally changed my teaching career. It was amazing, amazing. Hey there.
Thanks. You're a great presenter.
Thank you.